I want to take a look at the derivative just kind of from a graphical standpoint. Um, Even though I don't know what the formula for this function is, I may be able to get a pretty good idea of what the derivative function is. The thing is, I can see certain aspects of it. When I'm looking at the derivative, I'm looking at slopes of tangent lines. So I can see that, for instance, at this point right here, the slope of the tangent line is 0. I got a horizontal tangent line there. So in green here, I'm going to plot that. So the slope of that line is 0 right there. Likewise, I can see that the slope of the tangent line right here is 0, and right there is 0. That there's these spots that kind of jump out at me and say, hey, I can see very clearly what the slope is right at those points. Right? Now, when I'm looking at other points, let's start over here and say, look, to start with, it looks like I've got, at this point right here, I've got a fairly steep positive slope. Over here, it's not quite so steep, right? Over here, it's even less steep. So it feels to me like what's happening over here is that the derivative function is starting off, kind of big positive and working its way down to 0. Now, does it come down like a straight line? Does it come down bent this way? Does it come down bent that way? I don't know. I just know that it's starting pretty big positive slope, kind of steep here, but then it's going to work down to 0. Then, as I continue moving to the left, no, from left to right here, I can see the slopes getting negative. There's some point in here where it's as negative as it's going to be, as steep downhill as possible, and then it starts getting less. So these tangent lines are now have negative slopes, so the y value of my derivative should be negative, right? Because remember, this graph that I'm doing now, y equals f prime of x, that the y values of f prime are the slopes of f. So I'm looking at these slopes and making them my y value. Slightly negative slope, slightly more negative slope. So that's down here. I get to a point where it's as steep negative as possible. So that's the most negative y value. And now I'm going to come back to close to 0. These slopes are getting close to 0 again, so the y values come up close to 0. Then they get a little bit positive. And actually, it looks to me like through here I've got pretty constant slope. That is, it's doing kind of something like this, leveling off. Okay? Um, what's just happened? Grabbed the wrong thing. Right, this positive slopes here, but through here it looks like the slope is pretty much the same. It's almost like a straight line through there. And so I want to have pretty much a constant. The derivative is constant through there because the slope is constant through here. Now right here is a sharp corner, and we haven't talked about sharp corners yet. At that spot right there, we've got a positive slope on one side and this really big negative slope on the other side. And what happens is at that point, the derivative does not exist. That there's a sharp corner here. If I try looking at slopes of tangent lines, slopes of secant lines from the left side, or slopes of secant sides from the right side, they'd be doing two different things. And so at that point, you've got a break. There's no derivative at that point. But there is a slope to this side, there is a slope to that side. One of the problems as well is that that sharp corner is like lots of different tangent lines that you might draw in there. Each one of them has a different slope, so there isn't just one value that I'm getting close to. So anyway, there's a break in the derivative at that point. Then I'm looking at some really steep negative slopes getting closer and closer to 0. So the derivative has to be really big negative and then coming into 0. Then I see some positive slopes getting bigger and bigger positive, right? I see some positive slopes getting bigger and bigger. There's a spot here where you're as steep, as steep uphill as possible, and then it's starting to get less again. So the derivative then is headed, the derivative is headed up until you get to here, and then it's going to start coming back down again because these slopes are getting less positive. This is a slope of 3, this might be a slope of 2, and a slope of 1, right? They're getting smaller. Still positive, but smaller. And in fact, this looks like they're getting very close to a slope of 0 by the time it comes back down to 0, and it kind of sits right there for a while. All through this range here, these tangent lines look like they've got a slope of pretty much 0 there. So this comes down like that. Whoops, I've been doing that in green. Okay. Positive slopes, positive y value. Slope of 0, y value of 0. Negative slopes, negative y values. Slope of 0, y value of 0. Positive slopes, positive y values. Constant slope, constant y value. Negative slopes, negative y value. Slope of 0, y value of 0. Positive slopes, positive y values. Right? Slope of 0, y value of 0. Okay. The green function is the derivative of, well, it looks like a red function now that I've got all those little tangent lines drawn. The y values of this derivative are telling you the slopes of the original function.